Welcome to Summarize Science. Ever wondered why even the smartest AI chatbots can get confused by questions that require a few steps of logic? This fascinating paper provides a mathematical explanation and a clever solution. It all comes down to a phenomenon the researchers call the accuracy cliff. The task they study is called multi-hop question answering, or MHQA. This is where an AI needs to find and connect multiple pieces of evidence to find a single answer. Most AIs try to solve this entire complex problem in one single thought process. But this paper proves that AIs have a finite mental workspace or output capacity. As a task's complexity increases, the AI's performance doesn't just gracefully decline, it suddenly collapses. This graph shows it perfectly. Performance is stable and then sharply plummets right off a cliff. The researchers found this happens because of two compounding problems. First, the information load grows incredibly fast with each reasoning step. Second, even a tiny error in an early step gets amplified along the chain, leading to a completely wrong final answer. So to avoid this cliff, the authors developed a new framework called InfoQA. Instead of asking the AI to do one giant leap of logic, InfoQA acts like a guide, leading it through a series of smaller, manageable steps. First, it breaks the complex question down into simple, single-hop sub-questions. Then, it takes the clean answer from one step and uses it to form the next question, creating a transparent and controllable reasoning path. Finally, it discards all the messy intermediate thinking to keep the AI's workspace from getting cluttered. To prove their theory, they constructed a new, difficult benchmark designed to push these AIs to their limits. They systematically controlled the number of reasoning hops and the amount of distracting information. The results are incredibly clear, as you can see in this table. Standard AI prompting methods performed well on simple, one-hop questions, but their accuracy collapsed on more complex tasks. In contrast, the multi-step InfoQA method remained robust and accurate, consistently outperforming the others. In fact, their experimental results from the real world lined up almost perfectly with the theoretical curves they predicted. So, let's recap the important points. We've learned that large language models have a fundamental capacity limit when they try to reason in a single pass. Forcing them to solve complex problems all at once is a recipe for failure. The key is to break down the problem into smaller, capacity-aware steps, preventing information overload and error accumulation. This work opens the door for much more reliable AI systems that can tackle truly complex tasks. Imagine an AI that can accurately analyze scientific literature or complex legal contracts by breaking the logic down step by step. This multi-call approach could be a huge leap forward in the quest for true artificial reasoning. Thanks for joining us on Summarize Science.